5.4 is all about complex rational expressions. So what are complex rational expressions? A complex rational expression is just a fraction with fractions. We can say with the fraction or fractions within it. All right, so a complex rational expression is a fraction with the fraction or fractions within it. An example or examples of complex rational expressions could be something like 1 plus 5 over x, that's over 4x. Or maybe something like x minus y over x plus y, which is over 2x minus y over 3x plus y. Or maybe something like 3x over 5 minus 2 over x, that is over 4x over 3 plus 7 over 6x. So these are the types of problems that we're going to look at in this homework assignment, right? We're going to be working with these complex rational expressions. So how do we simplify? Well, the first thing I want you to do is identify your numerator and identify your denominator. Right, identify them. Identify your numerator. Identify your denominator. Right. After you identify them, rewrite the problem as a division problem. And now from there, it should be easy. You just follow the steps that you've learned in the past. Simplify each side. Then simplify the entire problem. Right, simplify each side separately. After you do that, simplify the entire. So let's take a look at the example. Anyone need another minute copying this down?
Yes.
All right.
Okay.
All right. Simplify. X plus 1 over 5, that entire thing is over x minus 1 over 5. All right, so we want to identify the numerator and identify the denominator. Notice at the top part, really we have this fraction line, this really long fraction line that says, hey, this is the numerator, that's the denominator, right? So we identify them. That's our first step. Second step is just write it as division then. So we're going to do the first part, x plus 1 over 5. It's that entire thing that's divided by this other one. Now from there, we just simplify each side. Right? We're already working with this here. You need to find the LTD. You take a look at that. Right? You only have one fraction, so the LTD here is 5. Right? So if we have x over 1 plus 1 over 5, all we're doing, multiplying this first one by 5. Because now that gives you 5x over 5 plus 1 over 5. Make that a little higher. In other words, it's just 5x plus 1 over 5. And so that's the first part there. All right, that is the first part there. Any questions there, y'all? Any questions? And now we do the same thing with the other side. The other side's pretty similar. Right there, LCD is also 5. But just like the previous one. We get here times 5 times 5. All right, so that's 5x over 5 minus 1 over 5, or in other words, 5x minus 1 over 5. Any questions there? And then how do we divide fractions? Well, we keep the first fraction. We change division to multiplication. We flip the second fraction. All right, this is just a little bit of review from 5.1. And now you notice 5 on top, 5 on bottom, cancel out. Answer here is just 5x plus 1 over 5x minus 1. Any questions with that example? A nice example there to start with. Let's take a look at our next example. Anyone need another minute copying this down? We have 1 plus 1 over x. That entire thing is over 1 minus 1 over x to the power of 2. All right, so we're going to rewrite this. All right, 1 plus 1 over x, dividing that by 1 minus 1 over x squared. And it pretty much looks like our previous example. The only difference is instead of numbers in the denominator, we have some letters. All right. Here, this LTD is x. Right, so, oops. All right, so we can turn this 1 into a fraction just by putting it over 1. But it looks like we're going to multiply that by x. Right, times x times x. All right, so it should leave us with x plus 1 over x. Any questions there? Any questions? All right, take a look at the next one here. The next one, LTD, there is x squared. So just like before, we turn that one into a fraction by putting it over 1. And this time it looks like we multiply both of these by x squared. It looks like we're left with x squared minus 1 over x squared. Remember, we're dividing. Any questions, y'all? Any questions? So we do the same thing that we did with the previous one, divide fractions. So we keep the first one, change division multiplication for the second one. Notice here that we can factor out that second one, right? Can't really do anything to the first one. But x squared is x times x. X squared minus 1 is x minus 1, x plus 1. So we can really do some factoring out with the second fraction. And now from there, we can start doing some cancellation. We have x plus 1, x plus 1. We have an x and the x cancel out, leaving us with an answer of x on the top and on the bottom an x minus 1. Any questions, y'all, with this example? And we'll do one more example here. Looking like this. Let's take a look. Simplify. How about 6 over x squared minus 49 minus 5 over x plus 7. That entire thing is over 5 over x squared minus 49 minus 5 over x minus 7. Same way, identify the numerator, identify the denominator. Right, so it looks like this would be 6 over x squared minus 49 minus 5 over x plus 7. It's this entire top part that we're dividing by the bottom part. I think this example is a really nice example because this covers a lot of sections here. I mean, I think it covers almost every section. It covers 5-1, 5-2. Just doesn't cover 5-3, but it covers 5-1, 5-2. It covers some sections in 4 as well. So it's a really nice problem. Starting with the left side, this side, right? We should be able to factor this first part out to x minus 7, x plus 7, right? Minus 5 over x plus 7. Notice that the LTD here is just x minus 7, x plus 7. Therefore, you should notice that this 5 is going to be multiplied to x minus 7. All right, so review from your last homework assignments. Try one fraction there. Any questions there? All right, we distribute, we're left with 6 minus 5x plus a 35. Right, over x minus 7, x plus 7. That look about right there, y'all? Negative 5x, yep, sure does. We're left with negative 5x, 35 and 6 is a 41 over x minus 7, x plus 7. Any questions with that first part there? And now we just repeat the process on the other side. Right, we start working on the other side. A pretty similar way. Right, this is 5 over x minus 7, x plus 7, minus 5 over x minus 7. We got the same LTD. And I'm just writing this in, but you don't have to. And just to help individuals that aren't certain on how to go about that. All right, so now we have 5 minus 5 times an x plus 7 over your LTD. All right, then we distribute that negative 5, leaving us with 5 minus 5x, what is it, minus 35? Right, so we have 5 minus 5x minus 35 over x minus 7x plus 7. And we're simplifying the top. The negative 5x minus 30 over x minus 7, x plus 7. Remember, we're dividing these two. Any questions, y'all? Any questions so far? All right, so some nice, a really nice example so far. And then from there, we just keep change flip. So we have negative 5x plus 41 over x minus 7, x plus 7, change division multiplication. We flip the second one. And I clearly see your cancellation there. Right, all of that on the top, that on the bottom cancel out, leaving us with the negative 5x plus 41 over negative 5x minus 30. It doesn't look like a vector's out of the program, so a nice example there. Any questions with that one, y'all? Any questions? I think this is a good one to practice. I'd be really comfortable with it. Does anyone need another minute copying this down? Okay, and then we'll look at one last thing here is difference quotients. Difference quotients is really something that's looked at in it's looked at in depth in a calculus class, but it does apply to what we're doing here as well, since we're dividing polynomials. And this difference quotients just is f of x plus h minus f of x over h. All right, so we're just going to do these separately, right? So for the function f of x equals 2x minus 3, I want you to construct and simplify the difference quotients. So we just start with first. Hey, we just say, hey, f of x is 2x minus 3. Second, f of x plus h, right, means all we're doing this entire thing, this x plus h, we put it into that x. So it's 2, open parentheses, x plus h, close parentheses, minus 3. And what does that equal? We distribute. We distribute, we get 2x plus 2h minus 3. Make sense, everybody? Now third, we can replace. All right, replace. Notice that f of x plus h is that entire thing. So now it's 2x plus 2h minus 3 minus f of x is that up there. Two x minus 3. The whole thing is over h. Does that make sense, everyone? And now from there, we just simplify this. What does that give us? Well, I got 2x minus 2x. That's gone. I have 2h only, so I write that down. Then I have a negative 3 minus a negative 3. Negative 3 minus negative 3. Well, that's gone. So all I really have left is 2h over h. Cancels out. My answer here is just 2.